If we take a look at hyperbolas, it helps to look back to ellipses. And if we notice the signs in our ellipse, you can see that the x squared portion and the y squared portion are separated by a plus sign, an addition sign. H and K are still the center. R sub x is the horizontal radius, and R sub y is the vertical radius. Well, hyperbolas work almost the same way. They look nearly identical, except that you can see that there is a subtraction sign. There's a negative. So hyperbolas can be distinguished from ellipses by looking to see, is there a subtraction sign? Now, it matters who has the subtraction sign. It doesn't really matter the order you write it in. In this second version, you can see they still kept the x squared portion first, and they just applied the negative there. So if the x part of it is positive, then it means it's going to be oriented a specific way. It means that your hyperbola, the curves are going to be oriented like this. Whereas if the y is positive, what you're going to do is it's going to be oriented along the vertical part of this x asymptote, such as this. So now for graphing. We want to look and see, well, what is the center? And we can see that there hasn't been a shift at all by looking at our x and our y squared. And so the center is going to be at 0, 0. And we're going to go over to 0, 0 and graph. And then our horizontal radius, we can see is, radius squared is 25, so the radius is 5. And our vertical one is going to be 9. Now, how does that help? We're going to add in a box. It says graph the center and use x and y radii, lightly draw a box. I'm going to try and draw it a little bit bolder just so that you guys can see how we're going to use it. So I'm going to go out 5 spots along the x, and I'm going to go out 9 spots along the y. So I'm going to go down 9 and up 9. And then I'm going to lightly kind of create a box. And we're going to use that for our asymptotes, which are going to lead us to our actual graphing of a hyperbola. Once your box is ready, what you're going to do is you're going to go from corner to corner and you're going to graph your asymptotes. And that's why we drew the box. The slope of our asymptotes comes from the corners of this box. We're looking at the radius. If slope is delta y over delta x, or the change in y over the change in x, well, we went up 9 and out 5. But in the other direction, we also went up 9 and back 5. So we have a slope of plus or minus 9/5 for these asymptotes, because at some stage they're going to ask you to write the equation of them. But right now, step 1, get your center. 2, use the radii to create this box and sketch your asymptotes, corner to corner. Our next step is going to be, what is the orientation of this hyperbola? And we look to see who's positive and who's negative. X squared is the positive portion, so it's going to be oriented like this. We're going to go to the sides of the x instead of the top and the bottom. So all you do is make sure that you can see your vertex. So as you can see in pink, I'm putting these little dots here. And now I am going to sketch a curve that includes the vertex and doesn't exceed the asymptotes. It just sort of uses them as a guide. So I'm going to start way up there, come in, continue out and along. And that's all that there is to it.